Good afternoon. Welcome to JCSF online tutorial class. So I remain my humble self, JS. I will be taking physics as usual. This afternoon we'll be talking about motion. In our previous class, we talked about position, distance, and displacement. So I'm trying to sort out to put the atmosphere in at peace because of the disturbance of the student in the school. Now, this afternoon, we want to talk about motion. Now, in our previous class, we talked about position, distance, and displacement. And we've tried to explain what position is, distance, and displacement is. So I'm supposed to go into that aspect of calculation. But what I just look about position, distance, displacement, distance and displacement calculation is just about addition and subtraction. Adding a distance to another distance, then you get a total distance. So adding a displacement which is in a normal direction. So for the reason we don't need to waste time on it, so we need to move to motion. So from there we can start the real work. So about the physics. From the motion, we can now move to work energy and power. Now, this is how we're going to talk about motion. And when we talk about motion, what is motion? What do we mean by motion? So, motion involves a change of position of a body with time. A change of position with time. So, when the body moves in the position, so with time, so we talk about motion. It also involves how things move and what makes them to move. So how this thing move from here down here and what caused this shock to move from here down here? That is what motion specify based on. So why a body moves and what made the body to move. It exists in different forms and occur in solid, liquid, and gases. Motion exists in different forms and it occurs in solid, liquid, and gases. So solid motion, liquid motion, like example in water, and gas motion. So that is where it can exist. So motion is defined as the change of position of a body with time. A change of position of body with time. If we put the body A here now, and it moves from point A to point B, now a change of position has occurred with time. Now, what has happened here now is motion. The body that is at point A is the one that still comes back to point B. That is what motion is all about. So it exists in different forms as I was saying earlier. So it exists in solid form, liquid form, and gaseous form. That is motion. Once again, motion is defined as the change of a position of a body with time. The change of a position of a body with time. That's a motion. Let's now talk about the types of motion. Let's talk about the types of motion. Types of motion. That's about the type of motion. Here we'll be talking about 5 types of motion. We'll be talking about 5 types of motion. We'll be talking about random. We'll be talking about random motion. Random motion. We talk about translational motion. We talk about oscillatory motion. We talk about oscillatory motion. We talk about oscillatory motion. And we talk about relative motion. We talk about relative motion. And we talk about 5 rotational. We talk about rotational motion. Now, here are the 5 types of motion that we will be looking into under the types of motion. Here are the 5 types of motion that we will be talking about under the types of motion. Let's all be taking them one after the other. I know that we have random motion, translational motion, oscillatory motion, relative motion, and rotational motion. Those are the 5 types of motion that we'll be discussing here. Now, let me start with the random motion. Let me start with the random motion. Now, when we talk about random motion, what does that mean? Now, a random motion is the type of motion in which a body moves in a non-linear manner and changes direction continuously. A random motion is the type of motion in which a body moves in non-linear motion. So, and the body changes continuously. Now, non-linear, for example, now, when something is moving like this non-linear motion, we can call it random motion. So it is not a straight line. When you talk about linear, that is on straight line motion. But this one now we are talking about non-linear, that is not on straight line. So it's a type of motion in which the body moves in a non-linear manner and changing direction continuously. That is a random motion. Example of random motion is molecular movement. Example of random motion is molecular movement in gas. Molecular movement in gas. That is one example of random motion. So another one is dashing of object in air. Dashing of object in air. That's another example of motion of random motion. Dashing of object in air. That's another example of motion. And we talk about that of dashing of object in air now. So we are talking about, for instance, we are talking about like insect or feather thrown into the air. When you throw an insect into the air now, or a feather into the air, you will see that the feather doesn't have a long weight. But when the feather is thrown to the air, you see how it moves. It moves in a random motion. So non-linear motion, it moves in non-linear motion. It's definitely applicable to the insect that is flying in the air. They move in non-linear motion. And such type of motion is what we refer to as what? Random motion. Such type of motion is what we refer to as random motion. So all the type of motion in which the body moves in a non-linear manner and changes direction continuously. In which the body moves in a non-linear manner and changes direction continuously. That is random motion. So let's now talk about translational motion. Translational motion. We've talked about the random motion. Let's talk about translational motion. Translational motion now. So, don't forget we are dealing with motion. We are dealing with motion. And motion is the change of position of a body with time. So it's the change of position of a body with time. And under the motion, we are trying to talk about the types of motion. But do not forget that I said that motion can exist in gas, in solid state, in liquid state, and in gaseous state. We are dealing with the types of motion, which we have talked about the random motion. And now we are moving to translational motion. So we talk about the random motion as a type of motion in which the body moves in a non-linear manner and what? And changes direction continuously. In which the body moves in a non-linear manner and changes direction continuously. So that is a random motion. Now we are moving to translational motion now. We are moving to translational motion now. And we talk about translational motion. What is translational motion? Translational motion is the type of motion which occurs when an object moves in a fixed direction. When an object moves in a fixed direction, we call it translational motion. So it's a type of motion in which an object moves, a type of motion in which in which an object move in the field direction. That is translational motion. It's a type of motion in which a body moves in a which a body moves in a field direction. In a field direction. When the body moves from a point to another point, so we said the body translates. For instance, when the body moves from point A to another point called point B, the body is said to be translated from point A to point B. What am I talking about? Let me say that this is a body A. Now, or let me say that this is a body, yes, body A. And the body moves from here to this point. So that we refer to as B. This is the body. A body moves from point A to point B. So the body is said to be translated from point A to point B. This type of motion is what we refer to as what? Translational motion. So a type of motion that occurs in the field direction. So in the field direction, when the body moves from point A to point B to point B, so the body is said to be translated from point A to point B. So whereby the body is said to be what? Translational motion. I hope you understand. So that is translational motion. So let's talk about the example of translational motion. Example of translational motion is the movement of a car from one point to another. If a car travels from one point to another, so the type of motion that the car travels is what we refer to as translational motion. So the movement of a car from a point to another. So human movement, or a movement of man. When I move from this way now to this way now, what I've done is what? Is translational motion. Because I move in the field direction. I move in the field direction. And that form of movement or motion is what we refer to as translational motion. So that is that about translational motion. I hope you can understand what we mean by translational motion when the body moves at a specified and field direction. So when the motion occurs in the field and in the field direction, that is what refers to as translational motion. Now let's move on to another form or types of motion. Another form of type of motion. Do not forget, we are dealing with the types of motion. We have talked about the random motion. And we say it's the type of motion in which the body moves in a nonlinear manner and changes direction continuously. When the body moves in a nonlinear manner and changes direction continuously. And we talk about the example. We say molecular movement in a gas. Molecular movement in a gas. That is one example. And dashing objects into here, like insect or feather. So when you throw a feather up, you see the movement of the feather. You see how it moves. It moves in nonlinear manner. And that's what kind of motion is random motion. Now we talk about that, and I explain now the translational motion. I think the type of motion which occur when our object moves in the field direction. So translational motion is the type of motion which occur when the body moves in the field direction. And I take a car as an example. When a car moves from point A to another point, it's an example of translational motion. When a man moves from one point to another, it's an example of translational motion. Let's move to another type of motion now, which is rotational motion. So when we talk about a rotational motion, what is rotational motion? So a rotational motion is a movement of a body in a rotational manner about its axis. A movement of a body in a rotational manner about its axis. The rotational motion about that is rotational motion, a movement of a body in a what? Of a body in a rotational manner about its axis, about its axis. That is rotational motion. Now, let me take a diagram to show you an example. Let's say that this is a circle now, and this is a load. This is a load. This is a load. This load is to travel in a rotational now. Here's a body now that is moving in a rotational manner. So around its axis. Now, this form of motion is what we refer to as what? Rotational motion. The body starts moving from here. I move in a rotational manner. It moves in a rotational manner. That is a typical example of a rotational motion. That's the example of rotational motion. Now, what are the examples? What are the physical examples? What are the physical examples of a rotational motion? The physical example of rotational motion is the movement of a car wheel. The movement of a car wheel. You can see that example of rotational motion. The movement of a car wheel. So it rotates around its axis. A car wheel rotates around its axis, and it's on one typical example of a rotational motion. Now, another one is the rotation of electric fan blade. Rotation of electric fan blade. That is another typical example of rotational motion. Now, the rotation of a car about a roundabout. When you get to a roundabout, let's say that this is a roundabout now, and the car is coming from this side. The car is coming from this side, and the car need to go to this side. You know, in a roundabout, a car is supposed to follow its lane. And when this car is coming from this side, I need to go to this side. Remember that the car needs to travel round the roundabout like this, before coming here. That's another example of rotational motion. That is another example of rotational motion. And another one is the rotation of the head about its axis. Remember that the head rotates around its axis. So they are all examples of rotational motion. Now let's talk about the next type of motion. Next type of motion. We'll be talking about the oscillatory motion. Oscillatory motion. Oscillatory motion. So what is the oscillatory motion? An oscillatory motion is a to and fro movement of a body about a fixed point. The to and fro movement of a body about a fixed point. What am I talking here? What are we trying to explain here? Now, something like this. Something like this. Now, let's say that this is the body. That is rotational motion. And the body is at rest here. Body at rest. The body is at rest here. As time moves on, we'll be talking about this. That is the uniform velocity, which is zero, always zero. So body at here, the body at rest. Now, I don't want you to get confused about this. Now, this body will be moving. When the body, let's know that the body is hanging on the thread. The body is hanging on the thread here. When the body is hanging on the thread, the point of the breath of the body will be at the center, as you can see here. But when the body is moved, we see that the body starts to be moving in to and fro motion. It goes like this, come like this, go like this, come like this, in the fixed direction. Go like this, come like this. This type of movement is what we refer to as oscillatory motion. This type of motion is what we refer to as oscillatory motion. But the center here is the point of rest of the what? Of the body. The point of rest of the body. Now, oscillatory motion occur or start when the body, which is at rest here, so is slightly displaced. When there is a slight displacement of the body, then the body will move in an oscillatory motion. Move in an oscillatory motion. To and to and flow. That is an example of oscillatory motion. The movement of a body, so in to and flow, the to and flow order at a fixed point. Now, example of oscillatory motion is a simple pendulum. A simple pendulum is one typical example of oscillatory motion. Now, vibration of plunge guitar string. Vibration of plunge guitar string. Guitar, those of you that used to hold guitar string, when you press it, you see that it moves in an oscillatory. It may move in a faster speed, but still, what it happened is a oscillatory motion. When you press the string, the guitar string, you see that the string move. So in fast speed, but it is definitely move in an oscillatory motion. It moves in an oscillatory motion. So it continues the movement until it comes to rest. And coming to rest, the body will come at the normal center. So from the beginning, that the displacement started from. That is another typical example of oscillatory motion. Another one is oscillation of load tied to a vertical string. Oscillation of load tied to a vertical string. When the string is at vertical order, like vertical form like this, and you put a load here, string. When the load is tied to the string, you see that the movement in the oscillatory motion will definitely occur. Oscillatory motion will definitely occur. Another one is kicking or punching the bag. Those of you that used to train buzzing, and if you punch a bag that is with load, and you hang it on someone, you hang the bag, and when you kick the bag, you see that it moves in an oscillatory motion. It moves in an oscillatory motion. That is oscillatory. Other examples of oscillatory motion. Now we can move to the last form or types of motion. Let me move to the last form or types of motion, which is relative motion. Which is relative motion. Now we talk about relative motion. Relative motion is a type of motion in which a body moves in relation to another body. Relative motion is a type of motion in which a body moves in relation to another body. That is what we refer to as a relative motion. Now, for example, now, a car traveling on a road is said to be in motion with respect to the pole and the trees on the roadside. What are they trying to say? So a car that is on motion, that is on the road, so it's trying to move in respect to the trees and the pole at the roadside. It maintains the middle of the road. So where the graphite is being tied. Now, the car now moves now in relation to another body, because if the car moves to the other side, definitely the car is going to hit the tree or the car will hit the pole. Now, the car must maintain the center of the road or in between the road. That is what the car needs to maintain. So relative motion is a type of motion in which the body moves in relation to another body. That is relative motion. Now, that is a typical, that is what a relative motion is all about. Let's talk about some example of relative motion. Pulling on a spinal spring. Pulling on a spinal spring. You know spinal spring? Probably in my next class, I'll be presenting some practical material so that all these things you can be getting to know them. Pulling on the spinal spring, that is a typical example of relative motion. When the spinal spring is pulled, so it is pulled in relation to the body, to the another body. Now, the pulling on the spinal spring happens through the effect of other bodies. That is a typical example of relative motion. Another example of relative motion is pushing of a block. The block that they put down and you push it and the block falls. So that is a relative motion. So the movement of the block occurs due to the relation of another body. That is you that pushed the block. I think with that you can get clearly to understand what relative motion is. If I drop a body and you push the body. Now, if you know that you push the body won't have moved. That is what we refer to as relative motion. Now, the body moves in relation to the body that pull it from the what? From the rest. From the rest. So that is what we refer to as a relative motion. Now, with that, we have come to the end of the types of motion. So far, we talked about motion and the types of motion. So we've explained what motion is, where I explained to you that a motion is defined as the changes of position of a body with what? With time. Changes of the position of a body with time. That is motion. Now, we talk about the type of motion, which we talk about the random motion, the translational motion, the rotational motion, the oscillatory motion, and the relative motion. Now, those are the types of motion we have discussed so far, and we try to look into the examples of those motions. Now, what we have been going to now is the causes of motion. The causes of motion. We try to look some part of it before the class comes to an end. Causes of motion. Causes of motion. Now, when we talk about causes of motion, one thing that should come to our mind is that what can cause motion? When the body is at rest, the body is not said to be on emotion. And until something is applied to the body, before you can say now that, oh, the body is now on motion. And if that is not applied to the body is not said to be on motion. What is that thing? And that is what? Force. A force must be applied to a body. A force must be applied to a body before the body can said to be in a motion. When force is applied on any object, it causes changes. When force is applied to any object, it causes changes. If I put this chalk on my hand here now, without moving it, the chalk will be there. But when I apply some little force, the chalk can move. That is the motion. Now, force causes the movement of the body. For the reason, the causes of motion is caused by what? By the force. Now, when another force is applied, the motion is changed as a result of the additional force applied. In order to overcome the first force, we are moving small, and that force is applied. When another force is applied, you see that the movement of the body that the force is applied to will be what? Will be changed. And this is the result of the additional force that is applied to the body. The additional force that is applied to the body. And that is what caused the motion. Now, that is what caused the motion. Now, force is a vector quantity. Force is a vector quantity denoted by F, which is the formula, which is the symbol, and it is measured in Newton. So it is measured in Newton. Now, we will be dealing going deep in this in our next class. As I'll be explaining little, I have to be rounding off the lesson because the time may come to the class may come to an end at any moment. Now, this Newton is the fundamental unit of force. Do not forget, Newton is the fundamental unit of force. While kilogram meter per second square is what? Derived unit of force. We have talked about this under fundamental and derived unit and quantities. So the fundamental unit of force is Newton, while the derived unit of force is kilogram meter per second square. Because we'll be dealing with force under motion. Without force, there is no motion. Force must apply before a body can move. That is one part of it. Now, here now, we will also be talking about the types of force. We will be talking about the types of force. We'll be talking about the types of force. Maybe we have to list the types out, and by next week, we start with the explanation. we have one. We have field force. So, and under the field force has subdivision, but we'll be looking into it in our next class. We'll be looking into the field force, contact force now. Now we talk about contact force. Contact force exists when there is a touch or hold or a contact with the object in question. When there is touch or hold or contact, so with the object in question, the object we are talking about, the body we are talking about, when there is contact, hold or contact, so or with the body, so that is it is referred to as what contact force. And it's also further divided into, we have like force, unlike force. We have frictional force. So it is further divided into contact force is further divided into like force. Not divided into like force, unlike force, and frictional force. Here are the type of contact force. So we have the like force, the unlike force, and the frictional force. Those are the three division of contact force that we have. Now, you should not forget we are dealing with the causes of motion, and we said that what can cause motion is force. Now we're trying to talk about the force now. So and we say we have some types of force. We are talking about the contact force and the field force. And under the contact force, we say the type of force that exists when there is touch, hold, or contact with the object in question. Touch, hold, or contact. So with the object in question. So when that kind of thing happens, we said it is referred to as well contact force. And the contact force is further divided into three. We have the like force, the unlike force, and the frictional force. Now, that about the contact force. As the time has not ended, we can still talk about the field force. The field force. Let's talk about the field force. Field force. Now, what is the field force? So, field force is in a confined or restricted to a given region or space. That is a region in space where a body experiences the effect of a force which occurs as a result of the influence of some physical agencies. Now, that is when we talk about it is what? It is a field force. Now, field force is unlike the contact force where we just touch the body.